Hey, what's up, geometry folk? We are going to be talking about just simple probability today. We've changed it from simple and compound to just simple. Okay, and over the next several days, we'll walk into the compound probability. The first thing that you'll need to know before we start talking about probability is something called a sample space. A sample space is the all possible outcomes in a problem. So, if you're thinking about a standard deck of 52 cards, your sample space is every single one of those cards. Okay? An event is a collection of successful outcomes to the problem. So, if I say I want a red card, then a success would be one of those red cards. So our sample space would be all 52 cards. But if I want a red card, then our sample space would only be the red cards. Now you know in a deck of 52 cards you have black and red cards. Half of them are black and half of them are red. So an event would be, or this event would only have 26 cards in it rather than the full 52 cards. A probability is when all outcomes, when outcomes are most likely. Well, really what this means is something is probable, okay, when something is most likely to happen, or greater than 50%. But you can find probabilities of that are less than 50% also. So basically you just take the number of ways or number of successes divided by the total number of possible outcomes. So in our example that we're talking about, our total down here would be the number 52. But our successes, we said that we only want red cards, and there's 26 red cards. So 26 goes on the numerator. And when we take 26 and we divide by 52, that will give us 1 divided by 2, or 50%, or 0.5. Okay? The next note is about a complement. Now this time we're not talking about complementary angles, and we're not even talking about helping people through giving them a compliment, telling them their dress is nice, right? This time a complement means not a success, or not the probability of the event not happening. It is not I didn't choose a very good example for the complement so far. So what I'm going to do is I'm going to change the example. Let's look at an example in the next slide, and I'll show you exactly what I'm talking about. Okay, so let's say that there are 4 kings in a deck of 52 cards, which is true. And let's say we want to find the probability that we pick a king. Alright? Well, in this case, picking a king is going to be our success. So we're going to have 4 ways that we could pick a king out of 52 cards. And that'll be our fraction, right? And we can find a decimal from that as well. Okay, so reducing this, a 2 goes into both. So this gives me 2 out of 26. And that reduces again to 1 out of 13. And if you want to see the decimal, it would be 0.077. 0.077. You could write it as a percentage as well, 7.8%. And the way you change a percentage into a decimal is you move the decimal 2 places. Or the way you change a decimal into a percentage, you still move it 2 places, but you have to be careful on which direction you move it. Okay? The way I think of a percent symbol is I think 7.8% means per 100. Okay? So that tells me to divide, and if I'm dividing by 100, that means I move the decimal to the left. Okay? So in this case it would be 0.078. And actually, oh, you know what? I just wrote the wrong number. So 77. Okay? So from there, we're going to say, what's the probability of there not being a king? Okay, so not a king would actually just be 1 minus 4 over 52. In other words, 1 minus 1/13. And 1 minus 1/13 is 12 out of 13. Okay, and if you don't see that, then you could basically just take 1 and subtract 0.077, and that could give you the answer. Okay, 1 minus 0.077, or 1 minus 1/13, is 0.923. And you could write 92.3%. Notice that a complement and its event, I should have said maybe it's an event and its complement, will always add to 100%. Will always add to 100%. So a complement and its event will always add to 100%. I like that. Let's put that in a book somewhere. All right? Anyways, coming back to your page of notes, that's what this probability means. Probability that an event doesn't happen is 1 minus that the event 1 minus the probability that the event does happen. Okay? Okay, so the first example that we're going to look at says that you select a letter at random from the letters shown. Express the following probabilities as a fraction, decimal, and a percent. So we have a bunch of letters, so that our sample space is actually just all those letters. Okay, our sample space is A, B, C, D, and E. So it looks like to me that there are 5 letters. So if there's 5 letters, that's how many total we have to choose from. Okay? Now, we need to know this word vowel. Okay? Well, vowels are going to be your A, E, I, O, U, and sometimes Y, right? So the vowels, there are only 2 vowels in here. So our fraction is 2 over 5. The decimal is 0.4, and the percent is 40%. Okay? Now the consonants, well, the consonants are going to be the other letters, B, C, and D. It looks like there are 3 of them. So that will give us 0.6, or 60%. Okay? Moving forward, we have jeans in a closet. Okay? This probably doesn't look as good on your paper as it does mine. But it says that he selects a pair of jeans with his eyes shut. Now, why would he do this? This is not true. Okay, so he didn't do it with his eyes shut, but a baby lived in his room, and all the lights were out, and he had to get dressed early in the morning, and this is my story of me. Okay? So anyways, you got to pick your clothes out with the lights off, right? So anyway, find each probability. It says that we have 2 blue, 3 black, and 3 khaki pairs as shown in the picture. So this actually helps us because they went ahead and told us our sample space is right there. Okay, so how many events are in our sample space? Well, 1, 2, 3, 4, 5, 6, 7, 8. So our denominator then is going to be 8, and the probability of picking a khaki would be 3. And 3/8 is a fraction. which gives us the decimal 0.375, and that gives us the percentage 37.5%. Okay? Sometimes you write this percentage symbol, and that's after you move the decimal to the right. Okay, so you don't write the percentage symbol next to your 0.375. Okay, so those are two very different things. Oh, well, these are the same, but okay, I think I was clear enough. Okay, so probability of picking a red pants. Well, I don't see any red pants in there, so that's just going to be 0 out of 8, which equals 0. And of course, 0, if you move the decimal any, it's still 0%, right? And then this says probability of not khaki. Well, if you're doing the probability of not khaki, then that means that you can pick blues and blacks and get 5 pretty easily, right? But let's do 1 minus the probability of khaki. Okay? We've already found that the probability of khaki was 3/8. So if I do 1 minus that 3/8, well, that's 8/8 minus 3/8, and that is 5/8. Did you have to do the question that way? No, absolutely not. However, in some cases, you're going to want to know how to use a complement, and that's exactly how to use it. Okay, so this is the decimal 0.625 or 62.5%. So the next example says that you roll a number cube once, and it says to find each probability. Well, you can't really find a probability without at least knowing the sample space. So when we look at a number cube, and if it's just a standard number cube, then our sample space is going to be either it'll have 1 dot on it, or a 2, or 3, or 4, or 5, or 6, right? So this is our sample space. So this tells me that my denominator is going to be 6 because there are 6 events that could take place. The first probability asked me to find a multiple of 3. A multiple of 3 would be 3 and 6, right? So this is asking me pretty much if what's the probability of getting a 3 or a 6, right? Well, that would be 2 out of 6, or 1/3, and as a decimal, it would be 0.333, or 33.3%. How about not a multiple of 2? Well, we can do 1 minus the probability that it is a multiple of 2. You don't always have to use this complement definition, but I'm using it in our notes so that you will get used to using it. So here I need to find the multiples of 2. Well, how many are there? 2 is a multiple of 2, 4 is as well, and so is 6. So that's 3 events out of 6. 1 minus 3/6 is like 6/6 out of 3/6. And this just gives me 3/6. Reduce it to 1/2. You can say that it's equal to 0.5 or 50%. Okay, so that's a bunch of different ways to write the same number, but that's it. Okay. The probability that I pick a 9, well, there is no 9 in our sample space. So we're just going to say that our probability would be 0 out of 6, which is the same thing as 0, or 0%. All right. The next subject that I'd like to turn our attention to is something about marginal probabilities and joint probabilities. Now, I understand that you do not have a template of notes for this, so just start on a separate sheet of paper and let's make this happen, okay? So for marginal probabilities, you're only going to get one letter. Okay? One letter. For joint probabilities, you'll get something like 2 or more letters. So let me show you exactly what I'm talking about. I'm glad you've already had some practice with Venn diagrams, because this is going to make a little bit more sense to you now that you've already previewed Venn diagrams. So let's just say that I put a 14, 2, 5, and 6 in this Venn diagram, and I asked you, what is the probability of A? Well, the probability can't be found until you have the total, right? So what I'm going to do is I'm going to write the word total on top of this Venn diagram, and I'm going to put that number up here. So how would I get the total? I'm going to add 14 and 2, that makes 16. 16 and 5, that makes 21. 21 plus 6 more is 27. So really, we have a total of 27. So our probability is going to be out of 27. And for this exercise, we're just going to leave all the fractions over 27, okay? So the probability of A is 16 out of 27. Now for some folks, that's very confusing, including myself. That was confusing for a long time for me because I always tried to pick this number. But this number does not represent the full circle A. So A, if you want to up here put a little parentheses in here and write 16, that's going to be helpful. Let's try to find the probability of B. This is also a marginal probability. So the probability of B is 7 out of 27. Now the rule for a marginal probability is that it only has to have one letter. So what if I asked you about the complement of A? Is that just one letter? Absolutely, it's still just one letter. So A complement is going to be 1 minus the probability of A. In this case, it's 1 minus 16 over 27. And what I like to think of when I'm subtracting from 1 is I just think 16 plus what number is 27? 16 plus what number is 27? Well, that'd be 11 out of 27. Now what we can do is we can go back to our picture and go count what is not in event A. Well, what's not in here? 5 and 6. So those two events are not in event A. That's why we're getting 11 out of 27. On to the next example. Probability of B complement is 1 minus the probability of B. And I'm running out of space, so 1 minus 7 out of 27. I'm going to think to myself, 7 plus what is 27? 7 plus 20 is 27, so 1 minus 7 out of 27. I found some, I'm going to write it. Okay, it is 20 out of 27. Now that's the answer, but now let's go back to the Venn diagram and check it out. We're going to use yellow. Okay, so 1 minus probability of B, so that means not in B. What events are not in B? Well, this 14 right here and this 6 right here. And 14 plus 6 is 20. Alright, so the picture is helpful, but also this 1 minus idea is helpful. Okay, now this marginal probabilities thing, that word is going to make so much more sense when we run into tables in the next couple of days. Okay, the next thing that you need to know is that joint probabilities is where we have 2 or more letters. So I'm going to write a few examples down, and then we're going to walk through them together. Okay, so here's a new page based on our joint probabilities. Joint means that it is still just one event, okay, but I have 2 characteristics that I'm looking for. Okay, so if I'm looking for two characteristics, in context, maybe I'm looking for a red king. Okay, so not the black kings wouldn't work, just the red king, right? So that's where they overlap, where maybe this one's talking about the red cards, maybe this one's talking about all the kings, and they would only overlap in one little section here, right? So A and B is going to be your 2 out of 27, and that's called a joint probability. A intersected with B complement, well, that would be everything else. 14, 5, and 6, or minus 2 out of 27, which is 25 out of 27. The next one is A or B, and we talked about the union of two circles, and we're going to add these two together, these three together. 14, 2 is 6, 6 and 16, 16 and 5 is 21 out of 27. Okay. Now this says not that part, so it'd be 1. I did it again. 1 minus 21 over 27, and that gives me 6 out of 27. Again, I do that so fast by saying 21 plus what number is 27, and that's 6. Okay. All right, now this is a little bit confusing. A, circle A, intersected with what's not in B. So it has to be in circle A, but it has to also not be in circle B. Okay? So here's circle A. How many of these is not in circle B? Well, if you're saying 14, then you're right on. Okay? So this is 14 out of the 27. Okay, and we don't need to write the decimals this time around. So 14 out of 27. And the next one, A complement, so it cannot be in circle A, but it has to be in circle B. So how many circle B numbers are not in circle A? Cannot be in there. Well, just 5. Okay, so on this one we're going to say 5 out of 27. Before we move on to the last couple of examples, I have something more to teach. So one more page and we're going to be through, guys. So stick with me. There's a property of complements that you'll need to know about. It doesn't come up often, but sometimes it can be a helpful thing to know. So this property of complement says that if each piece of a probability statement has a complement symbol, then the symbol can be taken out. So what if I did something like, you know what, I forgot what number we're on. So, okay, so number 7, the probability of A complement intersected with B complement. That's a little bit confusing to think about. Events that are not in A intersected with the events that are not in B. Well, what I do to tackle these problems is I rewrite it with a complement on the outside. So it's almost like factoring it out. Okay, it says taking it out, kind of like factoring it out. So now I'm going to write A without the complement symbol. The and turns into an or. And then the B complement, you're just going to write B there. So basically, we just need to do 1 minus the probability of A or B. Well, we know A or B, that's the union of the two. 16 plus 5 is 21. So 1 minus 21 over 27 is 6 over 27. And you might have seen that before in our previous page, right? We saw a 6 out of 27 right there because we knew how to find that. Okay, that's the beauty of using this property of complements. There's another way that another question that you might run into that has complements on both letters. So what if I said A complement unioned with B complement? Again, this is confusing to look at. So we can take out the apostrophe, much like factoring out an apostrophe, right? But this time we're going to say A intersected with B. And we know the probability of A intersect B. So we're just going to rewrite this as 1 minus the probability of A intersect B. Well, that's 1 minus 2 out of 27, which is 25 out of 27. All right, and that agrees with what we have in a previous page. A intersected with B complement is 1 minus 2 over 27, or 25/27ths. So that concludes today's lesson. I hope you guys enjoy it. God bless y'all, and stay clean and wash your hands. All right, later.